Well, and here we are working on the log worksheet from November 30th, and we'll start with number 2. And number 2 says that we have the log base negative 2x plus 5 of 81 equals 2. Alright, remember, to get rid of logarithms, we want to write this as an exponent. So what we have is the base, negative 2x plus 5 squared equals 81. Well, we can take the square root of each side, and that would give us negative 2x plus 5 equals 9. Negative 2x then would equal 4, so x equals negative 2. Okay. Now, moving on to number 4. Number 4 gives us the log of 3 plus the log of 4x plus 1 equals the log of 4. Okay, what I really want to do here is write this side as a single logarithm, and that'll end up being the log of 3 times 4x plus 1, and that's going to equal the log of 4. Now, what we have are logarithms of the same base on each side, and that means that what's inside each of the logarithms has to be equal. So, that tells me that 3 times 4x plus 1 must equal 4. Well, I can do the distribution here, and I get 12x plus 3 equals 4. So then 12x equals 1, or x equals 1/12. Now, on to number 5. Number 5, we have the log base 13 of 4 plus log base 13 of x plus 4 equals the log base 13 of 5. Again, I want to be able to write this left-hand side as a single logarithm. And I can do that. I can write that log base 13 of 4 times x plus 4 equals the log base 13 of 5. Well, again, log base 13 of 4x times x plus 4 equals log base 13 of 5. Taking the logarithm on each side, that must mean that what's inside the logarithms have to be equal. So we get x4 times x plus 4 equals 5, or 4x plus 16 equals 5, 4x equals negative 11, and x equals negative 11 over 4. And moving on to number 6. Now, number 6 is log base 7 of 7 raised to the 2x equals 4. What I can do is take this exponent out in front as a coefficient and get 2x times the log base 7 of 7 equals 4. Well, jingle my bells, would you look at that. Log base 7 of 7 is 1, which tells me now then that 2x must equal 4, so x equals 2. And moving on to number 7. Number 7 is the log base 2x plus 1 of 121 equals 2. Well, I'd really kind of like to get rid of that logarithm, so let's write this as an exponent. And that would be 2x plus 1 squared equals 121. Well, let's see. How about if I take the square root of each side? That would tell me that 2x plus 1 equals 11. Now if I subtract 1 from each side, 2x equals 10, x equals 5. Okay. So, moving on to number 8. Number 8 has the log base 7 of 3 equaling the log base 7 of negative 2x plus 5 minus the log base 7 of 6. Well, this time we're going to leave the left-hand side alone and write the right-hand side as a single logarithm. Log base 7, negative 2x plus 5 divided by 6. Alright, so log base 7 on the left, log base 7 on the right. Tells me that 3 is equal to negative 2x plus 5 over 6. Now let's multiply each side by 6. 18 equals negative 2x plus 5. So that tells me then that 13 equals negative 2x. So x equals negative 13 over 2, which would be negative 6.5 if you like. Alright. Moving on to number 9. And that's 343 raised to the x plus 5 plus 1 equals 50. Okay. 343 raised to the x plus 5 we could equal 49 if we move that one to the other side. Now, this is a good time to take a natural log. Okay. So, this would give us x plus 5 times the natural log of 343. That equals the natural log of 49. Instead of doing the distribution here, I can go x plus 5 equals the natural log of 49 divided by the natural log of 343. Right, we can do that because there aren't any x's on the right hand side. So then what we can do is just subtract 5 from each side, and x equals the natural log of 49 divided by the natural log of 343 minus 5. Now, that's one way of doing it. However, if we recognize something about this, I'm going to go 9 alternative. Okay. And that's 343 x plus raised to the x plus 5 plus 1 equals 50. Well, if we subtract 1 from each side, 343 raised to the x plus 5 equals 49. Now, 49 is 7 squared. 343 is 7 cubed raised to the x plus 5. Now, if you happen to recognize that, that's great. If not, the other method works just fine. So this would give us 7 raised to the 3x plus 15 equals 7 squared. So 3x plus 15 equals 2. So 3x would equal negative 13, or x would equal negative 13 over 3. Now, if you're doubting if those two things are equal, I encourage you to get out your calculator and check. Alright, number 10 is log base 7 of 7 raised to the 4x plus 5 equals 5. Now, again, we can take that exponent out in front as a coefficient, and we'd get 4x plus 5 times the log base 7 of 7, that equals 5. But remember now that the log base 7 of 7 is 1. So 4x plus 5 equals 5. 4x equals 0, so surprise, surprise, x equals 0. Okay. Now, that brings us to number 11. Number 11 is the log of base 3x plus 2 of 343 equaling 3. Again, we want to get rid of the logarithm. So we write this 3x plus 2 raised to the third power equals 343. Okay. At this point, we could take the cubed root of each side. So, the cubed root of 343, if you're not sure what that is, good time to get out your trusty graphing calculator. It's 7. The cubed root of 3x plus 2 cubed is 3x plus 2. So 3x would equal 5, and x would equal 5/3. Let's make that look like a 5. There we go. So x equals 5/3. That's number 11. Okay. Now, number 14, log base negative 3x plus 1 of 14 equals 1. Again, we're going to get rid of that logarithm. Let's write it as an exponent. Negative 3x plus 1 raised to the first power equals 14. Well, that means that negative 3x plus 1 has to equal 14. Negative 3x would equal 13. So x would equal negative 13 over 3. Okay. So, in this one, really easy to check. Negative 13 over 3 times negative 3 is 13 plus 1 is 14. Log base 14 of 14 is 1. And moving on down to number 17. We have the log base 5 of 5 equals the log base 5 of 6 plus the log base 5 of negative x plus 2. Now, again, we're going to look at this right-hand side and look at writing that as a single logarithm. Log base 5 of 6 times negative x plus 2. Again, log base 5 of 5, log base 5, 6 times negative x plus 2. The logs are the same, they're the same base, so that tells me that 5 needs to equal 6 times negative x plus 2. We do that distribution and we get negative 6x plus 12. So 5 then equals negative 6x plus 12. If I move the 12 over, I get negative 7 equals negative 6x. So x equals 7 over 6. And last but not least, number 18. Number 18 is 1/3 log x plus 1 equaling the log of 3. Well, that means that the log of x plus 1 to the 1/3 power equals the log of 3. Logs are the same, so that means what's inside them, or the arguments, have to be equal. So x plus 1 to the 1/3 has to equal 3. Well, to get rid of that 1/3 power, raise each side to the third power. That gives me x plus 1 equals 3 cubed, which is 27. So that means that x equals 26. And there you go. I hope you enjoyed this. Have a nice evening.